Hi YouTube, welcome back. Today we have a new videos. Today we talk about systems, new videos and system design crash course. Today we will talk about the vertical scaling via the horizontal scaling. Um, if you are new here, welcome. In this channel we try to give you the tricks and tips and teach you the how to answer any interview question and any interview and how to pass any interview that is related to software. And in this series we are creating a course to teach you about how about the system design fundamentals and main concept and main components and main methodology that we try to use to solve basic question in system design. And by the end of this course you will have a good knowledge of how to design a basic system and how to go to design and try to tackle any system design question that you face. If this sounds interesting for you, feel free to subscribe and hit the notification bell so you'll never miss a video, and let's start into it. So in the previous video we talked about the database, and we said that we need to have a server to store the data and another server to handle the traffic. So because of that we use the database to store the data, and we have this web server is to handle the traffic volume that coming from the mobile and web browser. After, let me copy this one. So after a while you discover that this web server cannot handle all the traffic. Let's say that we have a lot of different users, a lot of users, and all of them try to send requests to the server. Let me make it can I make it white? Yeah. Yep. And the server will be will maybe our server will not be able to handle all that traffic because there's too much traffic right now going through for the server. So how can we handle this? So there is two ways to handle this one, is to work with a vertical scaling or a horizontal scaling. A vertical scaling and a horizontal scaling are two different approaches to increasing the capacity and performance of a system, particularly in the context of server infrastructure and database management. They involve different strategies for handling increased workloads and demand for resources. So let's just talk about first the vertical scaling, which is called a scale up. So in the vertical scaling, that we could just add more resources to the web server. Maybe you can add more RAM, CPU, etc. So basically the definition of the vertical scaling is that vertical scaling is involves increasing the capacity of a single server or resource by adding more resources to it. This typically means upgrading the existing hardware by adding more CPU, memory, storage, or other components. The resource explanations, like you enhance the capabilities of a single machine by making it more powerful. For example, you might upgrade the server from 8 GB of RAM to the 32 GB of RAM, or from a dual core CPU to a quad core CPU. The advantages of this way is that it's simple. The simplicity, it's often easier to implement because you are working with a single machine or resource. The compatibility, basically the existing software and the configuration remain unchanged, minimizing the potential compatibility issues. And we have also the immediate gains. You can quickly achieve performance improvements with a hardware upgrade. Let's talk about the disadvantages, and which this will be quite a lot. So first, we have limited scalability. Like, we cannot add RAM forever. We will be limited at some point. So there are particular limit to how much you can vertically scale a machine. Eventually you will hit hardware constraints. The second thing is downtime. Like in some cases, upgrading hardware may require system downtime. The third thing, cost. Upgrading hardware components can be expensive, especially for high-end servers. The fourth thing, which is the most dangerous one, which is you have a single point of failure. Like if something happened to the server and the server went down, the full application right now freezes. You can't do anything anymore. There is other way to solve this one, and basically this, there is a lot of disadvantages, and here where the horizontal scaling or scale out comes into play. So let's assume that we have the DB here. Let's just make it here, and let's just delete this one so it will be easier for us to describe everything. So basically, how we handle the horizontal scaling is that by adding a new machines. So let me do it like that. Let's add 4 machines. Yeah. Okay. Yeah. Okay. And yeah. Can I delete this one? And this one will be connected here, and this one will be connected here. So as you can see here, we're adding more and more machines since the traffic is more. So basically the definition of the horizontal scaling is that horizontal scaling involves adding more machines or resources to a system to handle increased workloads. And instead of making an existing machine more powerful, you add more machines that work together. Resource expansions, you add more servers or instance to your infrastructure, often in a distributed and load balanced configuration. And in the next video we'll talk about what is a load balance and what is a load balancing. Each machine may be less powerful individually, but collectively they handle the load. The advantages, it's a scalability. The horizontal scaling is highly scalable and can handle large workloads by adding more machines as needed. Redundancy, it provides a redundancy and fault tolerance. If one of the machines fails, other can continue. So basically, if I have this machine that this server is working with this machine, so if this machine went down, basically this okay, let's go there. This user could connect with other machine, no problem, and it would not have any problem. The cost effective, like you can start with low cost hardware and add more as your needs to grow, making it cost effective. The problem that comes with the scaling out, it's that complexity, like managing multiple servers and load balancing can be quite complex. Software changes, like sometimes software needs to be designed or modified to support horizontal scaling. We have data synchronization, like ensuring data consistency across multiple servers can be quite challenging. So basically choosing between vertical scaling and horizontal scaling, like vertical scaling is good choice when you have a monolith application that can't easily be split into smaller components, or when your resource needs are within the capabilities of a single powerful machine. The horizontal scaling, on the other hand, is preferable for distributed system when applications and microservices where workloads can be divided among multiple machines. It offers a greater scalability, redundancy, and fault tolerance. And in practice, many modern systems use combination between both approaches, using vertical scaling to some extended and horizontal scaling to handle large and variable workloads. The choice depends on your specific application budget and growth, but I would say by default horizontal scaling is used more. This is by default. So that's it for today's video, and I hope you like my content. If you like my content, make sure to subscribe and hit the notification bell so you never miss a video, and see you in future problems.